In this lecture, we will discuss about exponential distribution. Exponential distribution. So this is continuous probability distribution. So we write down as this is continuous probability distribution. Now, so we explain this distribution first before writing the probability density function of this distribution. So the exponential distribution is widely used continuous probability distribution. Continuous probability distribution so it is often the time often to model the time elapsed between events. So we explain this as a continuous random variable, x with positive support. With positive support. So we explain a, we write down x such that x greater than 0 is useful in variety of applications. Various applications. So the major applications we discuss here. The first application, so we can calculate patient survival time, after diagnosis of particular कैंसर. ये रियल लाइफ एप्लीकेशन है इसके एक्सपोनेंशियल डिस्ट्रीब्यूशन. मतलब किसी भी पेशेंट का सर्वाइवल टाइम कितना होगा, कोई भी पर्टिकुलर कैंसर है किस तरीके से. सो सेकंड, द लाइफ टाइम ऑफ a light bulb. So when we see the life of a particular bulb rod, so we can obtain. So the third point, the time between births at a hospital. Fourth application, the number of gallon purchased at a gas pump. Or द टाइम, आप टाइम भी कैलकुलेट कर सकते हो किसी भी पर्टिकुलर बिल्डिंग को कंस्ट्रक्ट करने में कितना समय लगेगा, वी कैन टेक द हेल्प ऑफ एक्सपोनेंशियल डिस्ट्रीब्यूशन. सो द टाइम टू कंस्ट्रक्ट an office building or particular home. So these are the major applications. So we will discuss in exponential distribution. So we talk about the exponential distribution. What is the major thing? So we write down the common element. The common element associated with these random variable is that only have the positive support. Assume the positive support. Means we take the positive values, positive support. So the fundamental distribution with positive support is exponential distribution. Is exponential distribution. So this is the first distribution. ये पहला distribution है exponential distribution. उसके बाद हम क्या करेंगे, फैमिली ऑफ एक्सपोनेंशियल डिस्ट्रीब्यूशन डिस्कस करेंगे, जिसमें वीबल डिस्ट्रीब्यूशन होगा, गामा डिस्ट्रीब्यूशन, सो द डिस्ट्रीब्यूशन वी विल डिस्कस. दिस इज द फर्स्ट डिस्ट्रीब्यूशन ऑफ एक्सपोनेंशियल फैमिली. So is exponential distribution. So we can write down this as the gamma distribution. The gamma distribution also have the positive support. Have the positive support. The exponential distribution exponential distribution has a single scale parameter. Has single scale parameter that is lambda. Is defined as, so now we define the exponential distribution PDF. So a continuous probability random variable, continuous random variable x is said to have a exponential distribution, a exponential distribution with parameter, single parameter lambda, which is greater than 0. So we write this thing as x be a continuous random variable which have the exponential distribution parameter lambda. So the PDF, then the PDF पीडीएफ मीन्स प्रोबेबिलिटी डेंसिटी फंक्शन। आपको डिफरेंस पता होना चाहिए कि जब हम डिस्क्रीट डिस्ट्रीब्यूशन सॉल्व करते हैं या लिखते हैं तो वहां पे क्या लिखते हैं, प्रोबेबिलिटी मास फंक्शन, और हियर वी राइट डाउन द प्रोबेबिलिटी डेंसिटी फंक्शन। ओके विच, so pdf, so that pdf we represented as fx, function fx, which is equal to lambda e raised to the power minus lambda x, where x greater than 0 and 0 otherwise. So 0 otherwise. So we note one thing. One thing is that the lambda, parameter lambda referred as the rate. Parameter lambda referred as the rate in many applications. There's a growth rate. So lambda we refer as the rate. So now after writing the probability density function, we write the cumulative distribution function. So there are two terms. One is PDF, CDF. So second is CDF. So the exponential distribution has CDF, that is cumulative distribution function. Cumulative distribution function we denoted as capital F. PDF we denoted small f, that is denoted capital F x. This equal to probability of x less than equal to x. So this can be written as integral 0 to x and fx dx, means here we take the parameter fw dw. Okay, because our integration limit is x, so we change the variable function x into omega. So fw or dw or f omega d omega. So this can be written as integration 0 to x. So what is fx? So this fx is equal to lambda e raised to the power minus lambda omega. We can represent an omega. So into d omega. So when we integrate this, so lambda we take as outside from the integration. So now this can be written integration 0 to x e raised to the power minus lambda omega d omega. So this equal to lambda. What is the integration of e raised to the power ax? So e raised to the power ax upon a. So this we can write down as 0 to x. So this we can write as minus lambda upon lambda into e raised to the power minus lambda omega 0 to x. So this equal to minus, so e raised to the power minus lambda x or minus e raised to the power 0, or e raised to the power 0 is 1. So we write down as that fx is equal to 1 minus e raised to the power minus lambda x. So this fx is our CDF, cumulative distribution function. So this is our cumulative distribution function of exponential distribution. So 1 minus e raised to the power. So this we can write down as the CDF fx is equal to 0 when x less than equal to 0, and fx equal to 1 minus e raised to the power minus x when lambda x greater than 0. So this is our cumulative distribution function for exponential distribution. Now the mean and variance. So we calculate the mean and variance of exponential distribution So mean and variance of exponential distribution, we write on mean is equal to expectation of x is equal to, अब यहाँ पर हम क्या है कंटिन्यूस डिस्ट्रीब्यूशन के लिए सॉल्व कर रहे हैं, तो उसके लिए क्या फॉर्मूला होता है, इंटीग्रेशन ऑफ x इंटू एफ एक्स डी एक्स। और डिस्क्रीट के लिए हम क्या यूज करते थे, एक्सपेक्टेशन ऑफ x इज इक्वल टू समेशन ऑफ एक्स आई इंटू टी आई। सो दिस इज फॉर डिस्क्रीट, और कंटिन्यूस के लिए वी यूज द इंटीग्रेशन। नाउ what are the limit of integration? The integration limit, because x greater than 0, so means limit will be x equal to 0 to infinity, 0 to infinity x into fx। fx क्या है हमारा, lambda e raised to the power minus lambda x into dx। So this is our PDF, probability density function of exponential. So lambda is constant, we take outside, so 0 to infinity x e raised to the power minus lambda x into dx। So when we integrate this, so we can integrate, so we can use the islets. So this is for algebraic function, we treat as for differentiation. This is exponential function, we treat for the integration. Okay, so now we have the direct formula for integrating product functions. That means u we treat as a differentiation, we treat as a integration. So what is the formula? Formula is u first function into v1 for integration, one time integration, minus u dash one time differentiation of u, and to v2 two time integration of v, plus u double dash into v3 three time integration, minus u triple dash three time differentiation of u, and four time integration of v, plus and so on, or we till do this process when is the differentiation. So that means constant term will get. So now we use this formula here also. So lambda. So first function we write as it is. This is we consider as the u. So this is x we consider as the u, and this whole we consider as the v. So u into integration of v. So what is the integration of e raised to the power lambda minus lambda x? E raised to the power minus lambda x upon minus lambda, minus. So this is our second, minus differentiation of x. Differentiation of x is 1, or two time integration. So one time integration of this, again when we do again integration, so this gives us e raised to the power minus lambda x upon again minus lambda into minus lambda square. Now, so we no need to write the next term because this is our constant term। That means u dash constant आ गया, अब उसके बाद u डबल डैश करना, दो बार डिफरेंशिएशन करना, तो एक बार डिफरेंशिएशन constant है, अगले बार जीरो हो जाएगा। तो we stop the formula here and we apply the limits। So when we apply the limits, so we write down this x, so this gives us 0 minus e raised to the power minus infinity upon lambda square, minus plus lower limit because this is negative sign. So when we put x equal to 0, so this gives us 0 upon lambda, or minus plus, or e raised to the power 0 is 1 upon lambda square। So e raised to the power minus infinity is 0, e raised to the power minus infinity is 0, e raised to the power infinity is equal to infinity, or e raised to the power 0 is 1। So now we write down this as lambda 0 minus 0 plus 0 or plus 1 upon lambda square. So this gives us lambda into 1 upon lambda square is equal to 1 upon lambda. So the mean, that is mu or expected value ex of exponential distribution is 1 upon lambda। अब आपके दिमाग में एक चीज होगी, हमने डायरेक्टली यहाँ पर इसकी वैल्यू जीरो रख दी है, हाउ टू पुट दिस वैल्यू जीरो, तो वी कैन नॉट राइट डायरेक्टली जीरो। सो व्हाट टू डू, so when we take the limit x tends to infinity, x into e raised to the power minus lambda x। So now when we apply the limit x tends to infinity, so gives us infinity or e raised to the power minus infinity, so this gives us infinity into 0। So this is our indeterminate form, this is our indeterminate form। अब इस इंडिटरमिनेट फॉर्म को रिड्यूस करने के लिए क्या करना है हमें, या तो हम 0.0 करें या इन्फिनिटी अपॉन इन्फिनिटी. सो दिस लिमिट x टेंड्स टू इन्फिनिटी, वी कैन राइट डाउन दिस एज x upon e raised to the power lambda x. So now when we apply the limit, so this gives us infinity, or e raised to the power infinity is infinity. So infinity upon infinity. Now we apply the L'Hospital rule. So we apply L'Hospital, 0.0 हो या इन्फिनिटी अपॉन इन्फिनिटी हो. तो L'Hospital रूल क्या करता है, न्यूमरेटर को न्यूमरेटर में डिफरेंशिएट कर देता है और डिनोमिनेटर को डिनोमिनेटर में. दिस कैन बी रिटन एज लिमिट x tends to infinity, differentiation of x is 1, or differentiation of this is lambda x. So now when we apply the limit again, so this gives us 1 upon lambda into e raised to the power infinity. So this equal to 1 upon lambda into infinity, or something into lambda equal something into infinity equal to infinity, or something upon infinity equal to 0. So that's why we put directly 0 here. Okay, hope you understand. So this is the mean of exponential distribution. Now we calculate expectation of x square. So when we calculate expectation of x square, so this gives us integration 0 to infinity x square into fx dx. So this can be written as integration 0 to infinity x square into fx. So fx is lambda e raised to the power minus lambda x into dx. So this equal to lambda integration 0 to infinity x square into e raised to the power minus lambda x into dx. So this equal to, again we apply the same formula. So same formula, the first function we treated this as u and this as v. So this into integration of this upon minus lambda, or minus differentiation of first, or 2 time integration of second, gives us lambda square, plus differentiation of first 2 time differentiation of this u means 2, and 3 time integration. So 3 time integration means lambda cube. और constant आ गया, we stop the formula and apply limit 0 to infinity. Okay, so we write down directly here. So this we see that first term 0, second also 0, e raised to the power infinity 0. So this term also 0. For lower limit, minus minus plus x equal to 0 means 0. Next also having x is equal to 0, or this term having minus minus plus. So plus e raised to the power 0 is 1. So 2 upon lambda cube. So this gives us 2 upon lambda square. So this value is the e raised to the power x square. So this value is the e raised to the power x square. Now we calculate the variance. So variance is equal to sigma square. Sigma square is equal to e raised to the power x square minus e raised to the power x to the whole square. So this equal to 2 upon lambda square minus, or e raised to the power x we have calculated as 1 upon lambda. So this is 1 upon lambda to the square. So this gives us 1 upon lambda square. So this is 1 upon lambda square. So variance is 1 upon lambda square. Now, when we write down the standard deviation, so this will be the sigma 1 upon lambda. So lambda is the single parameter. Mean is 1 upon lambda. Variance is 1 upon lambda square, and standard deviation is 1 upon lambda. Now, this distribution have the memoryless property. This distribution have the memoryless property. Memoryless property. Memoryless property. Memoryless property means do not remember the past. So the exponential distribution we write down as the exponential distribution. Exponential distribution is memoryless. Is memoryless because the past no bearing on its future behavior. Future behavior. So every instant is the beginning of a new random period, which has same distribution regardless of the how much time has already elapsed. Okay, so basically, in short, we can say that talks about the conditional behavior of exponential, conditional behavior of exponential. Now, we have a memoryless property statement, so we solve the memoryless property. So for random variable x, follow the exponential distribution with parameter lambda and any two positive real number, two positive real number x and y. So probability of random variable x greater than equal to x plus y conditional x greater than equal to x is equal to probability of x greater than equal to y. So when we do the proof of this memoryless property, so we write down as we know that by conditional probability. So we heard the conditional probability, that means P A conditional B is equal to P A intersection B upon PB. Okay. So we know by using the conditional probability definition. So similar, we take the LHS side. Now we take the LHS. So LHS is that P random variable x we write greater than equal to x plus y conditional x greater than equal to x. So this is equal to we write down probability P. So A conditional B. So this we consider as the A, this we consider as B. So we write down this as x greater than equal to x plus y intersection x greater than equal to x upon PB. So P x greater than equal to x. So when random variable x which is greater than x plus y intersection x greater than equal to x. So now we can write down this as so P of x greater than equal to x plus y upon P of x greater than equal to x. So this we can write down by using the theorem, or we write down e raised to the power minus lambda into x plus y upon e raised to the power minus lambda x. So this we can write down as e raised to the power minus lambda y. E raised to the power minus lambda y. Now this e raised to the power minus lambda y, which is equal to the probability of x greater than equal to y. So this is our proof. Now you cross check the how to write this e raised to the power minus lambda y directly. So we can, so when we solve this for x greater than equal to y, so this we can write down as integration. So we take the value of random variable x which is greater than equal to y. So we start the limit from y to infinity. So y to infinity and of fw dw. So that means f omega d omega. So f omega means e raised to the power minus lambda omega or d omega. So this is equal to, we take a lambda outside from the integration and we integrate this. So this gives us e raised to minus lambda omega upon minus lambda and take the limit as y to infinity. So lambda to lambda cancelled. So we write down this as minus e raised to the power minus lambda omega y infinity. So where first we apply the upper limit e raised to the power minus infinity minus minus plus e raised to the power minus lambda y. So e raised to the power minus infinity is 0. So this 0 plus e raised to the power minus lambda y. So this is equal to e raised to the power minus lambda y. So hope you understand the value of this is e raised to the power minus lambda y. Similarly, you can write down the value of e raised probability of x greater than equal to x or probability p of x greater than equal to x plus y. You can solve this also.